Welcome into this journey into forces that govern the motion of celestial bodies. Today, we'll explore how gravitational forces between these bodies are described mathematically and how these forces influence Earth's motion. Let's get started. Gravity is the fundamental force that attracts objects with mass toward each other. This means every single object on Earth has got some force that attracts other objects toward its own center. Sir Isaac Newton's law of universal gravitation gives us a formula to calculate this force, and here is the formula. F equals to G multiplied by m1 times m2 divided by r squared, where F is the gravitational force, G is the gravitational constant, which is usually 6.67 times 10 power negative 11 per cubic meters per kilogram per second squared. M1 is the mass of the first object, M2 is the mass of the second object, and R is the distance between the centers of these two objects. Using this formula, we can actually calculate the force of gravity between the Earth and the Moon. In order to do this, we will have to understand how to assign values to the parameters of the formula correctly. F will be representing the force of gravity between the Earth and the Moon, that which we are trying to figure out. G will remain the universal gravitational constant. M1 will stand for the mass of the Earth, M2 the mass of the Moon, and R the distance between the center of the Moon and that of the Earth. Let's take an example here. We are going to give an example of the force of gravity between an apple and the Earth. Now, calculate the force of attraction between an apple of mass 100 grams and the Earth of mass 6 times 10 power 24 kilograms and a radius of 6,400 kilometers. We start by writing the formula first. F equals to G multiplied by m1 times m2 divided by r squared. Substituting these figures, we end up with F equals to 6.67 times 10 power negative 11 times 6 times 10 power 24 times 0.1 divided by 6,400 times 10 power 3 squared. Working all these figures using your calculators, you'll end up with an answer of 1.1 Newton. This is considered the force of gravity between the apple and the said Earth. The Earth and the Moon do not orbit each other directly. Instead, they orbit a common center of mass known as the barycenter. The barycenter is located closer to the Earth due to its greater mass. This shared motion creates a wobble on Earth's rotation, which affects its orientation in space. This concept of barycenter is crucial in understanding the motion of any two celestial bodies. Gravitational interactions, especially with Moon and Sun, influence Earth's orbit and axial tilt. These factors contribute to phenomena like seasons and long-term climate cycles. The Moon's stabilizing effect on Earth's tilt helps maintain relatively stable climate, something that is very essential for life. To summarize, gravitational forces between celestial bodies can be described using mathematical formula. These forces determine orbits, influence Earth's motion, and stabilize its tilt. The interplay between these forces shapes life on Earth. Thank you for watching. The universe is full of patterns and principles waiting to be discovered.